Dear students, today we are going to study Unit 2 of Explainable AI, which is Interactive Machine Learning and Beta Models. Before starting, I want you to remember one important thing. AI should not behave like a magic box. If AI give a decision, we must know why it gave that decision. So that is the main motivation of this unit. So in today's class, we will see how the humans interact with AI, how the AI learns with human guidance, and how black box models are explained. So please listen carefully. This unit is very important for your exam and the real world system. First, let us understand the problem with the traditional machine learning. So in traditional ML, we collect the data, train the model once, model give a output. That's all. So here, humans are not involved after training. For example, suppose we train a spam email or classifier, sorry, spam email classifier. If the model make a mistake, it keeps repeating the same mistake until retrained again. So now comes interactive machine learning, IML. So in IML, humans are involved during the learning. So the model asks a question, users give a feedback, the learning becomes the continuous and adaptive. So students, traditional ML, one-way learning. Interactive ML, two-way learning, because the model asks a question, users give a feedback. So this idea is called the human in the loop. Have you understood basic difference? Good. Now we go for deeper. Now let us formally define the interactive machine learning. Interactive machine learning is paradigm where humans actively interact with the learning process. Users give feedback, corrections or preferences. So the model updates itself continuously because based on their users feedback or users corrections. So instead of AI saying I'm correct, it asks am I correct? Have you noted the difference? Instead of AI saying I'm correct, it instead of that it asks am I correct? This is a very important right now. So in a real time example, very important for the student, think about the Google map. Okay, so when it show a route, sometimes we say avoid this road or this route has a traffic. So Google learn from this feedback, right? So avoid this road because this route has a traffic. So that is the interactive machine learn in action. So for the another example, medical diagnosis system. So in a medical diagnosis system, AI predict diseases. So doctor correct the diagnosis. Model retrains. Okay. So students, AI is a learning like a student from a teacher. Okay. Okay student, now let us see the how IML, interactive machine learning, works step by step, which means IML workflow. The first step, the model make an initial prediction. For example, AI predict the patient has a heart diseases, right? Step 2, users review the prediction. Doctor says yes, correct, no, wrong. And then step 3, the model updates its parameter based on the feedback. The model update its parameter based on the feedback. And then step 4, this process repeats again and again. So what happened finally? The model become accurate. The model aligned with the human thinking. Errors reduce the drastically. So that is called as iterative learning. Model becomes accurate, model aligned with human thinking, errors reduce drastically. Okay, so this is a very different from normal IML, right? So why do we need IML? because there are some advantages. So the first one is build trust. So the user trusts the AI because they are involved. Second one, learn human reasoning. AI start thinking like a human, not just a numbers. Third one, early error detection. So the mistakes are corrected before the damage happens. Fourth one, the dynamic adaptation. So it is very useful in fraud detection, healthcare and recommendation system. The finally, explainability. So users understand why the model behave in a certain way. So student listen, build trust, learn human reasoning, early error detection, dynamic adaptation, and then finally explainability. So interactive ML makes a AI reliable, transparent and user friendly. Have you got it? Now let us be honest. Every system has a limitations. So the limitations are requires a continuous human involvement and then time consuming. Designing the good feedback interface is difficult. Human bias can affect the model. Too much human control may reduce the automation. So student, interactive ML is powerful, but it must be balanced properly. Okay students, now we are moved to the second important topic of this unit. So far we say how the human help AI learn. So now we will see how humans understand the black box models. So for this we use beta models. So what is beta model? So beta stands for black box explanation through transparent approximation. Black box explanation through transparent approximations. Now, our student, what is a black box model? Already we saw in the first unit, deep neural network, CNNs and ensemble models. So these models give high accuracy, but we don't know how the decisions are made. So the beta involved solve this problem. So beta is a post-hoc explainability method used after training, build a simple and interpretable model to explain the black box. So beta does not change the model, it explains the model. Okay, very important. Beta does not change the model, it explains the model. Okay, now let us understand how beta works. So train a complex black box model. For example, a deep learning model predict the disease risk. Step 2. Apply the beta on the trained model. Step 3. Beta generate if-then rules. Already we studied if-then rules. Okay. So what is that? If a BMI less than 30 and BP less than 140, then the risk is high. Okay, then step 4, human inspect these rules. So students, instead of the seeing thousands of neurons, we see the simple rules. That is the beauty of beta, right? So beta uses a interpretable decision sets. Okay, so each rule is easy to understand, is faithful to original model and has a confidence value, right? For example, if age is less than 50, if age is greater than 50 and glucose is greater than 120 and equal to diabetes, yes, 0.92. Then 0.92 means the rule matches the black box model 92% of the time. So the students' confidence is very important for the trust. Okay students, now remember the points for your examination, which mean features of beta, which mean characteristics of beta models. What is that? First one, model agnostic. So work with the any black box. And then second one works for local and global explanation, right? And then third one is it is a very transparent rule sets. Okay, fourth one is faithful approximations. And then fifth one is human centered design, which means readable and actionable. So you can write this bullet points in your examinations. Features are characteristics of beta model. Okay, this is a very important comparison. Interactive ML and beta. Okay, the first point is our goal, right? Our goal used to learn interactively with the human input. In the beta, explain the black box via approximations. Okay, so it is used after stage. It is used during the training. It is used after the training. Okay, fine. Which means after the training call postcard. Yes, already we studied. Then feedback. Okay, human role. So human give a feedback. Okay, in the beta, the human interpret the rule, right? Then third one, the output improved the model performance, which means improve learning and the performance. Here explain the black box model. So simple memory trick I would like to tell you. IML, okay, interactive model learning means learning with the human. Beta mean explaining to the human, okay. The next one, applications of IML and beta. So now real world usages. Okay. So in the healthcare, the doctors correct the AI in IML. Okay. The rules explain the diagnosis beta. In the finance department, the fraud detection with the feedback for IML. In rule based, we have to use rule based auditing. So, in autonomous vehicle, so driver feedback is a IML. Explanation of decision is a beta. And legal and HR system, fairness, compliance, transparency. That are the real world examples. So, IML, for examples, IML used for the doctors correcting the AI result. Beta used to explain why AI predicted the high risk. Clear? So limitations of explainability. So explanations are approximation, not an exact. The risk of misleading or inconsistent is interpretations. It take a high computational cost, computationally expensive, especially for sharp. Human biases still exist, right? Hard to compare explanation across the domain. So the student's explanation is a support, not absolute truth. Clear? See the real world use cases. Finance sharp used for the loan decision transparency. In the healthcare, mainly needed the department healthcare. The healthcare, the grad come for medical imaging and diagnosis. Autonomous vehicle. So attention map explain obstacle detection. So NLP attention visualization in transformer bird GPT. Legal counterfactual used for a fairness audit. Okay, fairness, compliance and transparency audit. So in the final conclusion, let us conclude interactive ML makes a AI learn better. Beta makes a AI explain better. So both aim to build a trustworthy, what is the word? Trustworthy AI system. So please revise this unit carefully. Okay, so next slide we will solve a case studies also. Thank you.